In this video, we're going to talk about percent yield, which is basically what you got out of what you should have got, written as a percentage. Formally, we would write it as the actual yield, which is what is produced in a chemical reaction that you actually collect, over what you would predict or the theoretical yield. So, there's two types of problems we can do with this. One is just determining what the percent yield was, and the other is saying to assume a certain percent yield and calculate a problem that way. So, first example, if we have 52 grams of acetylene and you burn it and 80 grams of carbon dioxide is collected, what would the percent yield be? So there's a couple things you have to do in order to solve this problem. First is you have to write out the balanced chemical reaction for the combustion of acetylene, which is written here with the coefficients that you would need to have a valid ratio. But then what you would need to do is predict, based off of having 52 grams of acetylene, how much carbon dioxide you should make. And that'll be your theoretical yield. And then you're going to compare that to what you actually get to calculate what the percent yield would be. So, with 52 grams of acetylene, using the molar mass, there would be 2 moles of acetylene present there. Since it reacts in a 4:2 ratio, from here, 4 moles of carbon dioxide for every 2 moles of acetylene, we predict that you should be able to produce 4 moles of carbon dioxide, which has a molar mass of 44 grams per mole. That comes from 1 carbon and 2 oxygen, contributing to a molar mass of 44 grams. So, theoretically, you should be able to make 176 grams. However, since we only collected 80 grams, we would call this, we got less than half, that would be a 45% yield. So this is one type of problem. Again, what you got out of what you should have got as a percentage. Now, the other type of problem we can do, and there's actually more than this, these two, but these are just a couple examples of applications, would be if you assume, say, an 85% yield for a reaction. In this one, you want to determine the mass of aluminum required to produce 43.35 grams of aluminum oxide using this reaction. So, the synthesis of aluminum oxide. So this says for every 4 moles of aluminum I react, I'm going to use up 3 moles of oxygen and produce 2 moles of aluminum oxide. Now, what we have to do is kind of use the percentage as a conversion factor, because if we're saying we're actually getting 43.35, and that's assuming an 85% yield, we would have to make more. Like, you would have to make more predict that you would make more than that. So what we would do is we would write, if this is our actual yield, if it's an 85% yield, 85 grams would be what you actually get out of 100 that you would predict or theoretically be able to make. So your target would be, 51 grams of aluminum oxide would be what you should try to make in order to get the 43.35. Now, in order to do that, you just say 51 grams of aluminum oxide, molar mass is 102. That's half a mole of aluminum oxide. Using the reactions ratio, you would say you need 4 moles of aluminum to make 2 moles of aluminum oxide, and so therefore that would just be 1 mole of aluminum that would be required, and that would weigh 27 grams per mole. So you would need 27 grams of aluminum in order to make, theoretically you should make 51 grams from that amount. However, since it's an 85% yield, you can predict that you would actually obtain 43.35. So again, percent yield is what you should get, what you actually get, divided by what you should get times 100, and you can use it in a couple different ways.